Hi all, welcome back. This is the part 2 of how to do text mining. And today it's a simple extension of what we were doing last time. It's good to quantify information, right? So what we did in the last one is we figured out how to count words, and you probably thought, well, that's great, we can count words, what new? What now? Well, in social sciences, whenever we quantify information, we do so to make a comparison between two groups. In this case, we're not talking about people or societies or whatever, we're talking about words, we're talking about texts. So we're going to figure out a way to make comparisons between two texts. And it's actually, again, really pretty simple when you get down to it. So here's what we're going to do. We're going to split the Republic into parts. That will give us the grounds for comparison. We're going to count all the words in the parts, and then we calculate not just the count, but the frequency of those words. So this column, you recognize this sheet. This column is the number of words going right, and on this sheet, we have this all here. These are unique words, and then the frequency at which they occur. Frequency, is a fine count within a particular document to find the most frequent word. But if you're comparing between, or sorry, that's rate. That's just the count, right? The rate or frequency of the word appearing is the percentage of words in that word, the percentage of the whole document that word is. So if you have, 1,000 words and I appear 64 times, then it's 0.64% of the words in the document. And that's the term frequency. And so that's what we're actually going to be getting to. So this should really just say count or n, right? And then we're going to calculate the frequency, which we can do easily by saying equals this over sum that. And that gives you the frequency. So the math I did in my head is terrible. That's the percentage, and if you format and show it in percent, you'll get it 2.35%. So that's what we're going to do. We're going to calculate the term frequency, and then we're going to calculate the document frequency. And the document frequency is the rate at which that word appears in other documents. So if you have 5 documents and it appears in all 5, the document frequency is 100% or 1. If you have 5 documents and it appears only in the one that you're looking at, you have 0%, right? Because it doesn't appear in any of the other documents. So 0 other documents, and your document frequency is 0. And then the thing that we use to compare documents is called the tf-idf, and that's just the term frequency times the inverse of the document frequency, and that's right here. Term frequency times the inverse of the document frequency. So if document frequency is 1, it appears in every other document. This term goes to 0, and the term frequency doesn't matter, it's 0. If this is 0, it appears only in the one document you're looking at. This is 0, this stays at 1, and this is just then the term frequency. So it's a quick and dirty way to figure out which words are important to the section you're looking at. If a word appears frequently in the section you're looking at and nowhere else in any of the other documents, it will have its tf-idf is equal to its tf. And if a word is frequent in all of the documents, regardless of how much it appears in your section, the tf-idf will be 0. So it's a way to drop out common words, and it's a way to highlight words that are important to this particular document. And this is tf-idf is the measure we'll be using when we compare mission statements in other institutions. So I'm going to start with this one here. This is the Republic, Book 1 Republic that we did last time. It's complete, it's clean. Remember, that's all the most amount of work is cleaning, and we've done this and it's clean, and we've already got our stuff counting. Now you may remember, hopefully it was not that long ago, that when we did this crazy transpose formula, we had to limit it because of the limitations of Google Sheets. Now we're going to use that limitation to our advantage in this case. So we're going to split the Republic into books. Now these guys, I think we were just experimenting with, so I think I can delete. And this one was a previously used but not cleaned. So we have Book 1 Republic, and we have Sheet 2, which is the sheet that did our...
The honors program at Ferris State said new posts on ferrishonors.com. Free tickets to 9 to 5 for honors students, ferrishonors.com.
There you go, you heard it here, ferrishonors.com. If you didn't recognize that, that's our brand new Discord server, which should be announced today or tomorrow. See, look, you can subscribe to Discord and it will talk to you and tell you when cultural events are happening. So that's going out. There'll be an email today or tomorrow about where to sign up for the Discord server. Sorry for the interruption. Okay, so you remember reading the Republic. There's a couple of different people he talks to, right? The first person, they go down to do the sacrifice. Socrates and Glaucon are chatting. They meet Polemarchus and Adamantius. Adamantius is Glaucon's brother. Sorry, they don't meet him. He's with them. And they meet Cephalus. And Cephalus and Socrates get into a discussion, right? Now, we're going to break up the Republic Book 1 into the groups discussions. So the first discussion is Cephalus, and it goes up to right here, where this says Socrates Polemarchus. Is it not Polemarchus your heir? To be sure, he answered, and went away laughing to the sacrifices. So this is the last line spoken by Cephalus. So coming back over here, Book 1 Republic, we're going to look for, to be sure, ooh, that's not, oh, I gotta go up. Okay, the first instance of to be sure, he said, yeah, nope, one more. To be sure, is not Polemarchus your heir? I said, to be sure, and he went away laughing at the sacrifices. Okay, so this is the last line spoken by Cephalus. So we're going to mark that with a color. Now, I usually rant about color coding in Excel. It's a terrible habit, and you should never do it. In this case, I'm going to do it because I don't actually need to rely on this computationally. I'm going to put the numbers somewhere else. This is just visually so that I can see where the breaks in the argument are. So I'm just going to mark that line, and I'm going to mark this is the last line of section 1, so 39. So we're going to go over to sheet 2, which we've already done. We're going to take it and change it from line 100 to line 39, and that's just the discussion with Cephalus. I just spelled that wrong. Yeah, big time. Cephalus is Cephalus. I put the L in the wrong place. There we go. Okay. Then the next section, you remember, so Polemarchus takes over, right? Quite right, Socrates, if Simonides is to believe, said Polemarchus, interposing. And it's Polemarchus discusses with Socrates up into the point where Thrasymachus butts in. And here is where Thrasymachus butts in. He says he roared out to the whole company. Now I can tell you, because I've done this before, this is the only use of the word roared in the text. So we just, big document, we just look for roared. He roared out to the whole company, and there it is, 183. So 183 is the beginning of Thrasymachus's part. So we want 182. We want the beginning of Polemarchus's part. Oops, that's not well labeled, which is actually line 40. Line 40 is the beginning of Polemarchus. So we're going to, I clicked on the wrong thing. My bad. Okay, this goes up through line 39. Okay, line 39 to be sure, then tell me, okay, so line 40 through roaring, which is 183. Line 40 to line 183. And take this, duplicate it, name it Polemarchus, and it is line 40 to 183. Now we have a problem. The text of concatenate is longer than the limit of 50,000 characters. Now I'm going to leave that for now because I'm going to show you in a minute how we will remove common words. They're called stop words, and we're going to remove them before proceeding. But for this point, I want to set up the sheets first. So the next interlocutor, the next person who is in conversation, is called Thrasybulus. And if you remember, Thrasybulus goes on his little rant, right? You know, this is the great rants of Western literature. He starts out with roaring. Oh, it's 182. Polemarchus ends at 182, not at 183. 183 is the start of Thrasybulus. Thrasymachus. Thrasybulus is a completely different person. It's too early. This starts at 183 and goes to something. Let's just put it at 184 for now. It's not Thrasybulus, it's Thrasymachus. Thrasybulus was a democratic hero at this time. Okay. Thrasymachus starts out with roaring, yes. And then they talk about if you remember, Thrasymachus gives his argument, and then Socrates comes back and sort of starts responding to that argument. And so we kind of split up two pieces here, and the first is right up till here. Those were not his words, rejoined Marcus. And then Socrates begins questioning him. So we're going to go up to this line as Thrasymachus' part, and then we're going to go and keep the rest of it for Socrates. Thrasymachus' part starts at 183 and goes until, those were not his words. Okay, that's the end. So 236 is the beginning of the next section. So through 235, Thrasymachus is 2. Okay, that's the next section. Now we're going to duplicate this, and this is Socrates' response. And that begins where this one ends, which is 235. And I believe that section just goes all the way to the end. So the end is 492. And that one also is going to be too long. Okay, so now we're all set up. All of these sheets contain our 4 sections of text, right? So going back to book 1, what we're going to do is remove any stop words that appear. So I'm going to create a new sheet right here, and I'm going to call it stop words. Now, I'm going to give you a list of stop words. You can write your own. You can look online. There's plenty available, but I'm going to give you a sheet that has stop words. I'm going to put it right here. So you can copy and paste it out of this document, which I'll post online. And it's just a list of very common, bugger. All right, I'm not going to do that. I'm going to do it like this. So 131 common words in English, stop words. I'm going to take that, I'm going to go over here, and I'm going to paste it in. So that's just a big, long list. Now, in this one, back here, I'm going to insert a row. And what this row is going to be is it's going to be this, but removing any stop words. And go up to the top. So there's a nice little function that is, just a second. Sorry, I was getting confused with R. Okay, so there's a nice little function called regex replace. You remember I mentioned regex as regular expressions in the last session. Regular expressions is kind of it's a meta language convention that a lot of languages obey. So Sheets obeys it. It's connected to Perl historically, but no one uses Perl anymore. R has plenty of regex compatible functions. So it's not really any particular language, but it's useful. So we're going to say regex, and then what it is, the range of things, whatever it is we're going to use, which is this, right? So A1, and then what we're going to regex says, what's the string that you're looking at? What do you want to match, and what do you want to replace it with? Right? That's right, isn't it? Let me see. I'm getting the help. Where'd it go? All right, here. When in doubt, there it is. Yep, so what the string is, what you want to match, and what you want to replace it with. Now this dot star is just regular expression code for any character and any number of characters. Dot means any character, star means any number of characters. So this is any string that starts with A and ends with D, replace it with X, Y, Z. So what we're going to do, we're saying we're going to take this and we're going to match on, let's just use a simple example, the word I, right? And then we're going to replace it with space, or no, with nothing, and bang. And so I went down to Piraeus yesterday, and then this says, you are a philosopher. What? That is not, oh, I just overwrote it. That didn't work. Reg X, replace A1, word I with, oops, with, let's say I, yeah, and then nothing, and there. Yep, okay, so it took out the I and replaced it. I went down yesterday, right? So great. Now, one other thing that you probably noticed right away is I used the capitals. Regex in this case is case specific, so we don't want to match because we don't want capitals to be a problem, because, like, for example, the word certainly here, it would only match if it had a capital, and we want everything. We want it to match all I's, not just the, well, I is always capitalized, but we want it to match all words, not just the ones that start a sentence. And so we're going to take this A1 and we're going to say lower, and that just returns the whole string of A1 in lowercase, and then all of our matches are going to be lowercase. So you can see it says it went down yesterday. Now, in order to see, remember, this is what splits A into tokens. We're going to take this and we're going to move it to B. So it's going to be split the one that we removed the words on. And I went down yesterday to the place the son of Arist. Look, see, this now has matched the I in the middle of Ariston. And so we need to say, no, just match particular words, not the whole thing. And we do that with a regular expression convention, which is backslash S. Backslash S means space. So in this case, we're going to match any I that is preceded by or follows an S. Right? Sorry, is preceded by and precedes a space. So we're going to replace that now with a space, and you'll see come back for a minute, look back, Ariston, it still has its I, Mike still has its I, right? So we're not have a problem. But this is here. This one is not matching, and it's not matching because I is the first character in this string. So we need to say if it is a space or if it's the first character in the string. Regular expressions code, parentheses, allows you to take something like this and make it a phrase. So in regular expressions code, the caret, which is the shift 6, the caret means beginning of a string. And the vertical bar, what we call the pipe, which is usually shift backslash, is an or. So this says the beginning of the string or a space, I, and then another space. And we hit return, and it did take out that first I. So that's great. Now I'm also going to change, I'll leave that. We're going to change this to B because I want to know how many we're saving. So far we've saved 4 words. Okay, same deal though at the end of the string. The last word is wait. And if I come in here and put in wait, it's not going to match because it was the last thing in the string. And so we have to do the same convention, but for the end of the string. So parentheses, and the convention in regular expressions is a $sign for the end of the string. So either the end of the string or a space following the word wait, and scrolling right, it no longer ends in wait. So it removed the word wait. So that's great. That's exactly what we want. Now what we need to do is take this part, which is the actual word, right, and replace it with this whole list. And that's a little bit tricky. I'm gonna do a little trick. And so what I can do is we're going to concat all of those words into one big long string. So, sorry, we're going to concat everything in column 1 into one big long string, and then we're going to take that string and put it in place of the word wait on the previous sheet. And so it's not hard to do. You just do concat A through A, and then you have to say what you concat it by, what you add them together. So whatever I put in here, if I put in a bar like an or, right, I'm going to get a string. It didn't do the whole thing. 1 through a 131. Why is it not doing that? Okay, wrong expression. Sorry, concat only works, I guess, horizontally. What we want is called text join. Text join is a little bit different. Here's your example. It puts your delimiter first, and then true is whether it ignores empty, and then we're going to say true, and then the strings that we're going to do, right? So the delimiter is first. The delimiter is the thing that will separate them. So if I put an or in there, and then true because we want to ignore empty, and then A through A, we should get, oops, all of our stop words separated by an or, okay? Now, in order to make the, do that, go back, so that's right. So now to make this string understandable, we need to, by the regex, we go back here, we need each word to be separated from other words by this and by this, right? So we're going to take that and we're going to put that in here. And there, now that is the tail of any of the words. So I, end of string, and not space. And then the next one, and this is the tricky part. We're going to do this sort of inside out. You would normally think about wrapping the I in this and this, but the text join doesn't join anything at the beginning. It only joins the thing and then on. And so we're going to take this and put it here. And then each item, each word is separated by a comma. So what this does is it's going to say I, then it's going to take the value of this, I, and then it's going to input this, and then it's going to put the value of me. And if you put that together, you'll see, looking at me and on, each one is exactly what we want. Parentheses, caret, or space, me, end of string, or space. And then the comma gives you another value. So all of these are correct except for the first and the last, which are missing what? They're missing these regular expression pieces. But that's okay, because we put them in right here. So this is the beginning of the whole string. This is the end of the whole string. So we're going to take wait and replace it with and will allow us to reference a cell. So end quote and this cell. What is that? Stop words C1. Why doesn't it let me select? I'm missing something. My syntax is wrong. Look back where I did this before. Parentheses. Yeah. I need parentheses around the whole thing. Okay. What is this paren doing? Something went wrong. It tried to stick a paren in where it shouldn't. There should be a parentheses here, or there should be a quote there. And there should be a space, because that's what the replacement value is. Okay, so it says our first regular expression, beginning of the string, and then it says that whole big long string that we created, and then it says end of the string, right? And remember, that whole big long string we created doesn't have the regular expression at the beginning. It only has them in between. So the beginning and the end is missing the regular expression notation, which we've now added here and here. So this is replace in that any of the words that appear in the stop words in lowercase, and bang. Why didn't it do what I intended it to do? Okay, I figured out why it's not working. The comma isn't the right option here. Comma, I'm again confusing languages. The comma isn't the right option. We want this to be an or. because it's one big long regular expression, not a big long sequence of strings. So we're going to place that comma with an or, and now it worked. I went so the I has been dropped, went down yesterday to Piraeus. Right, so ding ding. And I changed, when I was debugging it, I changed this to 60. I want it back up to 1. It was 131, right? And do we have a memory issue? It looks like we do not. Yet went to the. Why is, oh no, here's another I. We do have a memory issue. It really, the should be a stop word, is it not a stop word? It is a stop word. We may have a memory issue here. Let me try something. Let's change this down to halfway between, let's say 70. There's still an I there. And there's still does there. So I'm going to solve something like this before. I'm going to take that and put that here. This one is A1 through 70. The second one will be A71 through A131. So the first half, so there's 2. And then we're going to run it twice. The first one on this column, the second one on this column. And then this will change to C. And this, that looked right. It dropped to 75. There. We're still getting an I. We got that. All right, so we're back. Sorry about that. I looked up, while I was away, I looked up what's going on here, and I think I've got it figured out. And what it is again, it's just too large for Google. So there's a couple of tricks we're going to use. This is going to be ugly, but it will work. So we're going to take this, right? This is where it puts them all together. And I tested it with S. No, let's leave it as S. I tested it with S. It works. But instead of going to a 70, I'm only going to go to a 30. It appears that about 30 lines is too much for the regex. The string's too long for the regex replace, and so it fails after that. Without an error, I can't absolutely prove that, but if I go up beyond 30 lines, it starts to fail. So with A1 through 30, and then I'm going to copy and put that here, and I'm going to go A31 through 60, okay, and then go back to the Republic, and this one is stop word C1, and this one is going to now be C2, and we're going to, yeah, that's okay, we don't need to $sign that, and we should have gotten rid of I, and my, where was the my prayers, so offer up my prayers, and so that's correct. If we go back, that's the words I was testing, so I is here, my is there, so it's getting both of those, and then at about 30 we got what, we got they, them, we got them. Let's see if them, offer my prayers to the goddess, but also I want to see what then they, okay, so they would celebrate, down to Glaucon son, offer prayers to goddess, and also wanted to see that what manner would celebrate. So them is missing, right? They would, sorry, they is missing, so it was taken out correctly. Now let's check one more. In this one we got which who. I know who is in the first. I went down to wait when we had, I thought who was in here. We, is we in there? All right, let's see, stop words. From 30 to 60, were is in there, definitely. Were and was. We're starting on our way home. Okay, so at the very end of this, it should have that removed. Servant, wait for, bid, where's home? Home, way, from a distance as starting on, from, well, it looks like were is not there. we're starting, right? Yeah, so it's missing. So it got ones from both of them. So what we're going to have to do, and this is inelegant, this is going to be messy, so we're going to take this, paste it, paste it, paste it, paste it, and we're going to go up by groups of 30. So 61 through 90, 91 through 120, right? 1 through 30, 30, 60, 60 to 90, 90 to 120. 121 through 135, which I think is about the end of it. Right? Yep. Okay. 1, 2, 3, 4. Did I miss anything? What am I thinking there? Yeah, okay. All right, so then this is the messy part. This one, this string, this command, right, returns something with all the words in one, all the stop words in one removed, right? So if we pass that along, that's what we're doing in blocks, to this one, which returns all the ones in two. Since we don't want to create tons and tons of rows and be really confusing, we're just going to embed this in another regex display, or regex replace. So regex replace whatever is the output of this with, copy that, put it right there, and that's going to change to 2. Okay, and then we're going to do it again. That, whatever that returns, comma, same thing again, but this time with 3. And then over here, this is now 4. And we're going to do that again. That whole thing, comma, place, and this is now 5. So all we're doing is just passing the string through this 5 times. Take all these first, then all these, then all these, then all these, then all these. And what we end up with, 64, a C1, I'm going to add a new column so we make sure we make a difference. Stick one in there. This is count A. Oh, did I have to do a split on that? Yeah, I had to do a split on that. Okay, here. Count A, and this is A1. So this is without any edits, all the stop words included. It's got 140 words. With the stop words removed, it's 64. And now let's look through and make sure that was. Why is was in there? Was it in C2? Okay, so I went, as you can see, I'd made a copy of the previous one. And I went back and saw how I did it prior to this, just to see if I'd missed a typo or something. So this is what we're looking at. A1 and stop word C1 and C2. This one, which I did before, is identical. So I'm just going to copy that, paste it here. Now I'm going to paste this in for you so you don't have to do this yourself. Regex replace function for column B of book 1 public equals that. And for column C, column C should just be C4, C5, and C6. Now, those of you who are paying attention will notice there are 6 and we only made 5, and that should not matter. Whoops. But I wonder if it does. So this is the one we're working with. That's there. And this, I'm going to put it here. That's B1, C4, 5, 6. And split lower C1. Why is this? C1. A1. Now already there's something funky because on my other one, I have 62 words remaining. This one I have 74. I wanted to see what manner was. Was is still there. What the? So let's look at stop words. Look, wait. I used a W. W is any non-word character instead of S. That might be the problem. Let's change these to W's. S is any space, any white space. W is any non-word character, so it would include other things like punctuation. It shouldn't really matter because we cleaned all that, but you never know with these things. Also, you'll notice when I pasted, the one I pasted had spaces. There's no real difference here. Is it updating? Why is it 74? Okay, so one of the things you may have noticed is that I had 6 lines instead of 5 lines, which is odd because I should have 5 lines. So I'm looking at it, and I'm looking at my other one, this one, the one that worked, right? And you look at stop words, and I got A1 through A30. I got A31 through A60, and then I got A31 through A60 again. And there's no reason why that should change anything, but I'm going to try it. Because it's completely duplicate, it should not matter. And let's just be precise, not say 136, it's actually 131. Never know. Now it's down to 63, look at that. And there's where the was should have been. So whatever, I don't understand. I'm gonna give you the stop words. I'm gonna delete these, which is what I was trying to diagnose. And I will give you the stop word commands. Here. Whoops. Yeah, that's not what I want. Those are the strings. What I want is the formula, so I want this. I thought I said 30. If I change that to 30, is it going to screw it up? No. Two 60s. I don't know why, it just needs that one twice. I wish I would traditionally blame Microsoft on these things, but in this case, Google's let me down. All right, let's see. There we go. Okay, those are your stop words commands. Copy and paste those in through C1 through 6, and these up here into A1 and B1, or sorry, into B1 and C1. And then this is our unedited word count, and this is our without stop words word count. So all we need to do is take these, paste them all the way down. Now, when I do this, it's probably going to take a minute to process. And it is. See, this is the process bar. That means we've got lots of calculations going on, and it's done. Okay. If it bothers you that it's a different font, it bothers me a little. I'm going to change all of it into, where's my font? I hate Corio. We're going to go with Arial. Okay. And And this one and this one we're going to copy. Oh, and this one now goes to C1. Do they all go to C1? No, they don't. So we're going to copy that one too. All three of those, all the way down to the bottom. And again, some processing lag. And there we go. So just scanning again. Do we have any lines that aren't big enough anymore? I think we got them all last time, but I just wanted to make sure. I'm looking here at column G to see if there's any that are throwing an error. I'm not seeing any errors, so that's good. Okay. Now, through the magic of Sheets, all of these should be updated, and you can scan again. I think I left not in. That's usually seen as a stop word, but why is that? Why is there an I there? But in doing philosophy, not is really important, so I left it in. I'm not going to get too bothered by it might just be that it hasn't updated yet. Okay, so Cephalus, Polemarchus, we have an error. Concatenate is longer than 5,000, and Thrasymachus and Socrates' response is longer than 5,000. So you're not going to be doing really large text when you're doing this for real. You're going to be using mission statements, strategic plans, and that kind of stuff. So you probably won't run into this. So if I were doing this like as a publication, I would figure out a way. I wouldn't be doing this in Sheets for one. I'd be doing it in R. But I'd figure out a way to concat these together through some magicry. But in this one, I'm just going to shorten the group that we're looking at. And I've done this. I figured this out where the limit is by just hunt and peck. You put in like 40 and it works, and you put in like 60 and it doesn't work, and then you go, kind of narrow down into the middle. So I know that 40 through line 62, 162 will work for Polemarchus, and for Socrates, we're going to go with lines 235 to 300. Now you'll say probably, hey, that's a whole lot of extra, and that's true. We could create a new sheet that goes from lines 301 to 493? Wouldn't be the, 492. If you really want to get that last section of Socrates in, it's not even good enough. Yeah, it's going to take a while. And this isn't, like I said, a super, I'm not looking at, I'm just using the Republic as a demo tool. I'm not going to find any, deep hidden truths in the Republic through this section. And when you're doing this for real, you're not going to be working with texts that are this long. There's an I there and there. I feel this is a rabbit hole. Okay, the main thing is that we now have all 4 sections, and we have our words, right? Unique words, and the number of times it appears in that section. So all the unique words and the number of times it appears in that section. 1, 2, 3, 4 in Sheets. So in this sheet, this is an old sheet from experiments I knew before. I'm going to delete it, and I'm going to create a new sheet. Where did I put my sheet? There it is. And we're going to call that calculations. And all we need to do is bring in the values of B and C for each of Cephalus, Polemarchus, Thrasymachus, and Socrates' response. And that's really easy to do. You just go index, Cephalus, A and B, comma, and index is going to give you a range of cells and rows or columns depending on what you selected. So we're selecting Cephalus AB, that whole section, and we want the first column. So it always goes index the range, and then row, and then column. And so the first row we're just going to leave blank because we want all rows. We just want column number 1, and that gives us Cephalus number 1. Oops, you know what? It's not AB, it's BC because we want the unique ones, not everything. There we go. Now we got the unique ones in row 1, and then I'm just going to put dollar signs in front of this so that when I copy and paste it to this row, it doesn't change, but this time we want row 2. Right. Okay, and now I'm going to take that, I'm going to copy and paste it here, and I'm going to change this from Cephalus to Polemarchus. And change it to 2. And then I'm going to take that and whoops. And I'm going to change Polemarchus to Thrasymachus. And again, change that one to 2. And then this one is Socrates' response. And change that 1 to 2. Okay, so these are our 4 sections, right? These are the 4 things we're going to compare. And so now what we're asking ourselves is what words in, say, Cephalus don't appear in the others, and what words in, say, Polemarchus don't appear in the others. Now, one other thing I'm going to do here, because we're going to get a lot of columns going, so I'm going to shrink these guys just so we can see a little better, right? And I'm going to mark them. This is Cephalus, and this is Cephalus N, and this is I'm just going to P. Polemarchus, and this is PN, and this is T, and this is TN, and this is S, and this is SN. Okay, just to make sure I know what I'm doing, I'm just calling that C, and I'm going to call it CN. Okay. This structure, we're going to replicate. We have to calculate. Remember what I said at the beginning of this? We first we split the Republic into parts. Done. Count all the words in that document. Done. That's right here. That's what these N's are. This is all the unique words, and this is the number of times they appear in that document. We're going to calculate the document frequency. Document frequency is how many times this word appears in the other documents. So I'm going to put these here because we're going to do it for each section. We're going to do it for Cephalus, we're going to do it for Polemarchus, we're going to do it for Thrasymachus, and we're going to do it for Socrates. So the first thing that we do is we're going to use a function that just says countif, right? And countif says, see what the order goes in. It's first the range and then it's the criteria. So the range for countif is going to be this whole thing, A through H. Now I'm just going to be a little bit careful. I'm going to say A3 so we don't have the headers in it, right, through H. So the whole of H, this whole block, see, it's going to go all the way down to the bottom. It's got all our documents in it. So A3 through H, that's the whole range I'm looking for, and I'm going to say if it matches A3. The word turned, the number of times the word turned in this whole big orange section, right? And it tells me 2. Now I know that it appears in document 1, which is C. I want to know how many appears in documents other than 1. And so since it appears here, I can just calculate that by saying countif and then subtracting 1. So it appears one other time in one other document other than the one that it's actually in. Now I'm going to adjust my formula a little to make sure that when I copy and paste it, it stays that way. So what we're going to do is we're going to put $1 on A and $1 on H and $1 on 3. That's going to keep the range exactly the same, but we're going to let A and 3 vary. So when I copy it, it changes that, but not the A3 and H. So I'll copy this and put it here, right? It changed C3, which is correct, Polemarchus, but it did not change the range, right? So the word tell appears in 3 other documents, and guess what? There are only 3 other documents, so that's good. So we're going to take this, and we're going to put it there, and we're going to take it there. Now these N's, this is just coming over from here, right? And so we're going to calculate what we call the term frequency. This is the CN, this is the straight count. We want the frequency. The frequency is like the percentage, right? So I'm going to put that in for all of those. Just to make this easier to read, I'm going to bold them and center them. Okay, so the term frequency is the number of times the word turned appeared in its own document, right? So it's 1 over the sum of B. And just, sum of B colon B. And again, just to be a little on the safe side, we're going to say B3, colon B. So the number of times it appeared over the total number of words in the document, and it will give us a percentage. I'm going to change that so we can see it into percent. There we go. So that, I didn't put any dollar signs in, you'll notice. Actually, I will. I'm going to put a dollar sign in there to define the range as the whole. I want this to vary because I'm going to copy and paste it to Polemarchus and Thrasymachus and Socrates, and I want the B's to vary because I'm going to copy it to the other ones as well. But I don't want the 3 to vary because I want the purple to start at row 3 on each one. So I'm going to copy that, put it here, and put it here. And then we just have to check. So it's saying this value over that whole, this value over that whole, this value over that whole. Great. So now I can take and copy all of these, scroll all the way down until we run out of words. Socrates is the longest, so it goes down to here, profit, and paste. And that will fill out the whole thing. Don't worry about all these ones that have negative ones or zeros. They'll drop out when we do the processing. Now again, just so we can see things a little bit better, I'm going to shrink these down, and I'm going to center align them. So this is now not the document frequency, it's the number of documents that word appears in. So we're going to call it DN rather than DF. Okay. Now we need to calculate DF. DF is the document frequency. You have 4 total documents, so it appears 1 over 4 appears in 25% of the documents. So again, that's going to be really simple. We're just going to take this, we're going to paste it, and instead of DN, we're going to call it DF, document frequency. And that is the number of documents it appears in divided the total number of documents, which is 4. And you have 25%. I'm going to change format number percent. There we go. And I'm going to center align it too. Now that formula J3, J is going to vary because I'm going to paste it here and here and here, and it's going to hit there, there, and there. And 3 is going to vary because I'm going to paste it up and down. 4 we don't have to worry about because 4 is the total number of documents and it doesn't change. For TF, that's the data we want, so we're just going to carry it with us, right? So we're just going to say, you don't have to do this. You do have to leave the column blank, but you don't have to do this copying the TF data over. It's just, in my mind, a little bit cleaner to keep them together. So there we go. So that's the whole group, and we can go down to where the numbers run out and paste it in. So we have the document frequency and the term frequency, and see, document frequency, term frequency, then we just have to calculate tf-idf. So we're going to take this and we're going to shrink it, right? And then I got to add some extra right columns. Okay, I'm going to copy these headers, stick them here. The header is, what we're calculating is the tf-idf, and I want the actual term back because we want to be able to paste to see what it is that we're calculating. So we're going to, there we go, copy and paste that. Now the tf-idf is now really easy to calculate. All you have to do is take the term frequency, multiply it times inverse document frequency, which is 1 minus the document frequency. Right? Now why is that? Because the document frequency is, if the document frequency is 100%, 1 minus 100% is 0, and the term frequency means it's a common word, but it's common everywhere, so uninteresting, so its value will be 0. If the document frequency is 0, meaning it appears only in the document that you're looking at, then 1 minus 0 is 1, and your value will be the term frequency itself. So that's why it's the inverse document frequency. So that's the formula, T3 minus 1 S3, and the term is, of course, A3, right? Now, when I copy and paste this, this is going to change both of those. That's okay. It'll become U, and 3, and this is going to change to 2 on, A, B, C, and it will be tel. Okay, so we should have a value of this times this times 1 minus this, and the word tel. Yep. Now, this, as you can see, formatting. These are going to be sometimes really small numbers Oh, sorry. We got to turn it back on to number. Yeah, format. All right, I got it. Never mind. All right, we got to turn these to number. More formats. There we go. You're going to be, we're talking about percentage of words, right? So they're going to be small percentages, but that's okay. You'll see in the end, you can still sort them. So we're going to hit that and all the way down, whoops, all the way down to where the numbers run out. I already copied it, stick it down there, paste it all in. All right, now we got the tf-idf and all the words. Now we want to sort, we want to discover things. So we're going to take that whole thing and we're going to create a new document, a new sheet called results. And we're going to paste it. Whoops. My bad. We're going to paste special values only. There you go. Now for any of these, we're going to put this back in. Any of these, you can take 2 and sort. Data has header rows. Sort by tf-idf. In this case, it's only reading the top header. That's okay. And sort. And what you find is that the words that are used most frequently when talking to Cephalus that do not appear in the rest of the text are age and old. And of course, Cephalus. And wealth and acquired and youth. And if you remember, what they talked about was the differences between youth and age. Data, sort range. And what did Paul Marcus talk about? He talked about doing evil to your enemies and good to your friends. And harm friends. Data, sort range. And Thrasymachus talked about whatever is in the interest of the stronger, and that government and justice and rulers and subjects have to obey their rulers and all of that, right? And then Socrates, format, or data, sort range, data has header row, descending. Art, interest, ruler, injustice, shepherd, medicine, physician, etc. So there it is. Each one of these brought forward the basic theme of what that section was, and the words that were used to discuss that theme. And that's what we're going to do when we start looking at colleges, because we're going to look at the kinds of words that are distinctive to those colleges. You can call these keywords or whatever. They're words that are distinctive and frequent in a certain section of text or a certain document, and not in other documents that we compare against it. So that's it. Thank you all, and I'll see you next class.